Hi, this is Mr. Dinsmore. Today we're going to be doing long division using the partial quotients method. This basically means that we're using smaller division answers, which are the quotients, to solve a larger problem. We do the same thing with multiplication with partial products, in which we multiply smaller numbers to create the answer to a larger multiplication problem. So let's get started. The number that we are going to be splitting 7 ways, or one way to look at it is if I had 651 items, I would be sharing them among 7 people. How much would each person get? That's the number that we're dividing right now. To do this, we're going to rewrite it differently. And we're going to write it the way that it would look if we were traditionally dividing a larger number, by writing 651 here and putting 7 off to the side. And this is going to allow us to divide the 7 with the 651, starting from larger place values and working our way over. Now, in traditional division, we would just continue from here and we would be putting our numbers on top. However, with partial quotients, we are going to have this line on the side that's a little different. But this allows us to understand why we move numbers down in long division based on place value. So let's go ahead and get started. Okay, so first what we have to look at is these key steps and ideas. One is we're going to start at the largest place value. So we're going to start over in the hundreds and then move to the tens and the ones based on if we can use these numbers and divide them with the 7. Next, we're going to look at making sure that we try to divide by the largest number possible. If I'm giving things away to 7 people, I want to give away the largest amount so I'm not dividing as much, because the more you divide a number, the more likely you're to make mistakes when you go to do it. So it's best to use math facts and divide with the largest possible number, and that way there's less steps. And then finally, in this method, instead of dropping the number down, we are actually going to be adding zeros based on place values to understand why we bring numbers down in long division. And of course, as we get these answers, we're going to multiply them and subtract them off the total, because what we're doing is giving away chunks of this 651 as fast as we can until we get the answer. So let's go ahead and look at this and say, okay, we have 7 and 6. Well, if I'm looking at 600 and I'm looking at 600 doesn't divide very easily by 7, or even the number 6. So I'm going to move over to 65. And now I can look at a math fact and say, what do I multiply, or how many times do I count by 7 to get as close as I can to 65 without going over? Well, if I know my math facts, I could say, well, that's 9 times 7. So I would write down a 9. In long division, I put it on top, which we'll learn later, but for now we're going to write it on the side. However, if you notice, this was 65, but our answer is actually 651 here. And the 65 is really not 65, it's 650. So therefore, we're going to put a 0 on the end of this 9 to compensate for place value here. So what we're going to do is we're basically going to give away 90 of the 651 to each of the 7 people, but we now need to multiply the 7 by 90 to get the total amount given away. So when we multiply 7 times 90, we first do 7 times 9 and then just add the 0, because it's like multiplying by 10 after, which is every place value, right? So 9 times 7 is 63. And because we have this 0 here that needs to be put here, that creates that spot where this number would be brought down in long division, but it's forced to come down by the fact that we're accounting for its place value. Now what we do is, since we've now given 90 things away to 7 people, and that makes 630 items given away of the 651, we just subtract and say, okay, we gave away 630, so now we have 21 items left. So once we give away the 21 items again to the 7 people, we will have the total amount of items that each person gets and the answer. Well, 7, well, if I look at 7 and I go look at 2, well, 2 is smaller than 7, but if I go to 21, I can say, hey, what times 7 would be 21? Well, 7 times 3 equals 21. So if I now multiply back the 3 to that 7, I'm going 7 times 3. And if you notice, there's no 0 here, so this is why I'm not adding a 0, because 7 times 3 is literally 21. And so once I multiply the 7 by 3, I subtract the two numbers, and I have no remainder. That means there's no items left that would be, if I split among 7 people and I had a leftover item, that would be considered a remainder. And you can deal with those differently depending on if it's an item that you can share. So since I have no remainder, I just simply now take the 90 that I gave to each person and the 3 that I gave to each person, and I add them together. And that gives me the answer of 93. So therefore, if I had 651 items and I shared them among 7 people, each person would get 93 items. This is how you do partial quotients, and what I do like about this is it does force the 1 to come down by accounting for place value. And you can see it's very similar to long division, except we are just adding our numbers on the side versus writing them on top. I hope this was helpful, and we'll continue to practice this. You have a great rest of your day.